Good afternoon, everyone. So, welcome to your lecture number 5. And the topic of today's class is actually hidden in this quotation. So, let's just read the quote first and try to understand what the topic of today's class is. Now, he says, when you have eliminated the impossible, whatever remains, however improbable, must be the truth. In fact, we'll read the quote again. He says, when you have eliminated the impossible, whatever remains, however improbable, must be the truth. In fact, this line was given by a very famous detective that I think you know, and that is Sherlock Holmes. Right? And he is basically talking about a very famous method of proof, which is proof by contradiction. Right? Or the other name is reductio ad absurdum. I think that's the Greek or the Latin one. I don't know. So that's the other name. And my favorite name of this proof is actually proof by impossibility. So we are going to talk about this method of proof by contradiction, which is known by this, and my personal favorite, proof by impossibility. Right? In order to understand this, I will take up a very simple question. Right? So write down the first question. First question is, prove that there is no largest natural number. Yes, I said, prove that there is no largest natural number. We know the statement, there is no largest natural number. That is so obvious. I am just asking you to prove it. This is mathematics, right? You can't say this statement is obvious. You need to prove it. And I've already given you a hint, because I've given you the method of proof, which is proof by contradiction. Right? In order to better understand this method, I'll start with a very simple statement, which is wrong action yields wrong consequences. Very simple, and I think most of us would agree. Obviously, there would be some who would disagree with that, but let's just bear with it, right? Let's just understand, and we think that it is absolutely true. Read the statement. He says wrong action yields wrong consequences. In fact, we'll apply this statement in this question. Now, we'll start with wrong action, right? I need to prove that there is no largest natural number. Now, the wrong action in this case would be, I need to prove there is no largest one, right? The wrong action would be that there is the largest natural number. For my wrong action, I will take, let there be a largest natural number. Right? So there is the largest natural number. Let me name it to be, say, n. Right? When I say that n is the largest natural number, how do I understand the statement? N is the largest natural number, which implies that if you take any natural number except for n, it would be smaller than this number. Right? So what I'm saying is any natural number, obviously except for n, I've written it, must be less than n. Right? Simple? Alright. Now let's just think about it. N was there. Now any natural number. Let's see. Natural numbers, if I move from 1 to 2, I'm adding 1. If I'm moving from 2 to 3, I'm adding 1. Right? This is how we proceed in natural numbers. I add 1 and I get the next natural number. Now let me see. N is there. So, n may, if I add 1, natural number, right? Definitely this is a natural number. Right? Addition of two natural numbers gives us a natural number, that is the closure property of the set. Right? So, n plus 1 is a natural number, and this number is definitely not n. So that means it comes into this category. Any natural number, it comes in this category. Any natural number must be less than n. So this is my natural number, and you are saying n plus 1 must be less than n. minus n on both the sides. I can add and subtract the quantity in the inequality, that is absolutely fine. I will get 1 over here on the left hand side and 0 on the right hand side. You have arrived at this 1 less than 0. 1 less than 0. Obviously, this is what? A wrong consequence. Right? This is called the wrong consequence. Now the question is, why did this wrong consequence arise? Because of your wrong action. And the wrong action in this case was, you suppose that there was a largest natural number. Right? And this is what method of contradiction is. In fact, this statement is actually a little bit on the moral side, right? We cannot use this statement in mathematics. So let me change my wording a little bit. Now, wrong action becomes wrong assumption. Right? And my wrong consequence actually becomes the contradiction. So he says wrong assumption yields contradiction. So you started with the wrong assumption, which was there is the largest natural number, and you arrived at this, which is obviously a contradiction. Right? So this is what proof by contradiction is. You start with the wrong assumption and you arrive at a contradiction. This implies that whatever you assume, that is wrong. You assume that there is a largest natural number, right? This statement is wrong. So that means the true statement is what? That there is no largest natural number. Natural number. Such a simple technique, but a beautiful one. In fact, this method of proof by contradiction was obviously talked about Euclid, because whenever there is some problem, Euclid would have some opinion on it, which is a good thing for us. And in fact, there is a mathematician, G.H. Hardy. He says, out of all the proofs, methods of proofs, this proof by contradiction is the finest weapon a mathematician could have. Why? Because whenever you are stuck, this problem, this method comes to the rescue. And it is so beautiful that you can even prove a statement like this, that there is no largest natural number. It is so obvious, but yet you can prove this by proof by contradiction. Right? So using this, we'll be moving on to the next question, which is prove that, obviously a very important question for class 10. It will definitely come in the school exam, so we have to be a little bit careful. He says, prove that root 2 is not a rational number. Prove that root 2 is not a rational number. Hurry up. Mind it, in this question, writing is also important, so you should know what you are writing, because you need to get full marks. And I should not be telling you this, obviously you have to prove by contradiction. That means you start with the wrong assumption. Right? You need to prove that root 2 is not a rational number. The wrong assumption would be that root 2 is a rational number. So, suppose, or if possible, you can write, if possible, wrong assumption, root 2 is a rational number. Right? In the junior classes, I have talked about the form of the rational number. Right? So, root 2 can be written as ratio A by B, where obviously A and B are integers, or we can say positive integers if you want to write it, where obviously B is not equal to 0, and HCF of A and B is 1. Now this is a very obvious thing. Any rational number you take, you can always write the rational number in lowest form. Lowest form means it should not have any common factor. If it does not have any common factor, that means the HCF is 1. I have made sure that this rational number is in my lowest form. Right? Now, if I have to proceed forward, here a radical sign is getting involved. Not a big fan of that. So what I'll do is, in order to remove the radical sign, I'll square it up. Right? So root 2 whole square, that is 2, is equal to a by b whole square, so a square by b square. Right? I can cross multiply this. So this becomes 2b square is equal to a square. Right? Now we have arrived at this equation which I must use somehow in order to proceed further. Now mind it, left hand side is equal to right hand side. Right? Whatever prime factors are there on the left hand side must be present in the right hand side. Right? 2 is present over here and 2 is the prime factor. That means 2 must be present on the right hand side as well. Right? So that means a square has the prime factor 2 in its prime factorization. Right? Now mind it, in the prime factorization of a square, 2 will not be alone. There will be more 2. Right? At least 2 to होंगे. It might be 4, it might be 6, it might be 8, whatever. Right? At least 2 2's will be there. Right? Mind it, if a square has the factor of 2, do you think a would have the factor of 2? Of course. Right? Now, if 2 is present in the prime factorization of a, that means 2 will divide a. So I'll move on to this one. Again, 2 is present in the prime factorization of a square. That means 2 divides a square. Right? Because prime factorization mein aakar ho raha hai. That implies that 2 must divide a. Right? Because if 2 is present in the prime factorization of a square, it has to be present in the prime factorization of a. Because इन दोनों के prime factors तो same ही रहते हैं, double हो जाते हैं इसमें. That I agree, but same रहते हैं, right? Alright. So we have arrived up till this point. 2 divides a. Now mind it, if 2 divides a, that means if I want to factorize a, it would be 2 would definitely be there into some integer. Right? So k, मैंने इसे बोल दिया, k is an integer. Right? Now, if I have to proceed further, I need to use proof by contradiction, and I have arrived at this point that a has a factor of 2. Right? If I am able to prove, because I need to have a contradiction, I am able to prove that even b has a factor of 2, my problem will be solved. Now, I will try to do that. Let's see. A is equal to 2k, I have arrived at here. What I can do is, I can substitute this value in equation 1. Substitute in equation 1. Right, which was 2b square as it is equal to a square. Instead of a, I'll write 2k whole square, which is nothing but 4k square. Right, so b square turns out to be 2k square. Now again, left hand side is equal to right hand side, right? Whatever prime factors are here, they should be present over here. Now, 2 is here, that means 2 must be here. So that means 2 divides b square. Now, again on the same lines, if 2 divides b square, that means 2 is present in the prime factorization of b square. Will 2 be present in the prime factorization of b? Answer is yes. And if it is present, that means 2 will divide b. 2 divides b. Right? Now, here you are saying that 2 divides a and 2 divides b. That means 2 is a common factor of a and b. 2 is a common factor of a and b. You said that? Now wait a second. यहाँ पे क्या था? FCF of a and b, you supposed it to be 1, right? That means there is no common factor. And you have arrived that there is a common factor. That means this is a contradiction. Right? Now why did you arrive at the contradiction? Because your supposition was wrong. What was the supposition? That root 2 is a rational number. Now this is wrong. That means the correct statement should be, it should be root 2 is not a rational number. Right? I am hoping that you will pause the video now and then proceed further, because you need to revise the proof. You need to see whether you have understood the entirety or not. Right? Okay. Now, the next question is, prove that root 3 is not a rational number. Now, instead of root 2, you need to talk about root 3. Right? Pause the video, write the solution yourself, and then check whether your solution matches with mine, whether you have written all the steps or not, because that is very important in such kind of questions. Right? Again, same reasoning would work. You will write root 3 as a and b. So here it will be 3. here it will be 3, here it will be 3, here it will be 3. Easy for me, right? Because I'm working on a blackboard. So again, you will get at 3 divides A. Same argument you will give and you will arrive at 3 divides B. That means 3 is a common factor of A and B. That means which is a contradiction. And contradiction is there because your supposition was wrong. So on the same lines, I am leaving up that to you. You can complete it. Right? Now, let's proceed further. Prove 2 plus root 3 is an irrational number. Mind it, you have just proved that root 3 is a irrational number. Using that, you need to prove this. Come on, hurry up. I think sufficient time, right? You need to prove that 2 plus root 3 is a irrational number, right? That means I will start with the wrong supposition. So my supposition would be, if possible. Now wrong, I need to prove that it is a rational number. Wrong linear, so that means I will suppose it is a rational number. Is a rational number. Right? Wrong supposition, that means whatever you have to prove, just assume the contrary of it. Irrational proof is irrational. Done? Okay. So that means 2 plus root 3 can be written as ratio of two quantities, A and B, where obviously A and B are positive integers. And B cannot be equal to 0. You need to write it. You cannot run away from that. Don't worry. Right? Now, I know something about root 3, right? Root 3 is irrational. So what I do is, I will try to isolate it. So I do not want to transpose it. So root 3 is equal to A by B minus 2. Right? Now, definitely this is a rational number. Now, 2 is also a rational number, right? I can write 2 as 2 by 1. This is a rational number. Difference of two rational numbers will give me a rational number. Closure property again. So, difference of two rational numbers giving me rational number. So, right hand side is definitely irrational. Left hand side, you just proved that root 3 is irrational. So, irrational. Now you are saying irrational is equal to rational. Definitely this is a contradiction. Which is a contradiction. Why? Because your supposition was wrong. You suppose that 2 plus root 3 is a rational number and this is wrong. That means 2 plus root 3 is not a rational number. Or you can directly say 2 plus root 3 is an irrational number. Same thing. Right? Now the next one. Again, prove that 3 root 5 is an irrational number. Provided you know that root 5 is an irrational number. On the same lines, you can prove that root 5 is also an irrational number. I think sufficient time, right? 3 root 5. So again, I will suppose the wrong thing. That means I will suppose that 3 root 5 is rational. Right? That means 3 root 5 can be written as the ratio of A and B, where A and B are obviously positive integers. Right? And B is not equal to 0. Now I know something about root 5, so I will try to isolate it. So put 3 in the denominator. So root 5 is equal to A by 3B. Now mind it, this is an integer, right? And 3B is also an integer. Ratio of two integers, when this is not equal to 0, obviously, ratio of two integers will definitely be a rational number. Now, right hand side is rational, left hand side, irrational. Irrational equal to rational. Obviously, this is a contradiction. Why? Because your supposition was wrong. Your supposition was 3 root 5 is rational. This is wrong. That means 3 root 5 is not rational. Right? Done. Next one. Prove, now this is an interesting one. Prove root 6 is an irrational number. Come on. I think you can pause the video and then proceed further. I will discuss it. So on the board now, right? Prove that root 6 is an irrational number. Again, I will go by proof by contradiction, right? So that means I will assume the wrong thing. That means I would assume that root 6 is rational. The wrong thing assume karni hai, so root 6 is rational. That means root 6 can be written as ratio of two quantities A and B, where A and B are integers, obviously, B is not equal to 0, obviously, and HCF of A and B is equal to 1. Because I can write any rational number in the lowest form, and I will do that, right? Obviously, not a big fan of radical signs. Square it up, cross multiply, I'll get 6B square is equal to 8 square. Right? Mind it. Now you'll say, ma'am, 6 divides A square. Mind it, we always talk about the prime factorization, right? Because fundamental theorem of arithmetic, right? That involves prime factorization. So that is why instead of talking about 6 itself, I will talk about the prime factors, which is 2 and 3. Because left hand side is equal to right hand side. Whatever prime factors are present over here must be present over here. So I will go to the prime factorization because I need to use the fundamental theorem of arithmetic. Decomposition ही करनी होती है numbers की, right? So I will do that in terms of prime factors, right? And there is another subtle point also which we will come towards the end of the lecture, right? Now, obviously 2 is present on the left hand side, 2 must be present on the right hand side. That means 2 must divide A square, right? 2 divides A square, okay. That means 2 is present in the prime factorization of A square, right? If 2 is present in the prime factorization of A square, will it be present in the prime factorization of A? Yes, it will be. So we can say that 2 divides A. Right? We have a right that this 2 divides A. That means I can write A as 2 into something. So 2 into some integer, that is K. K is an integer. Right? What I'll do is I will substitute this in, let me call this equation 1. So equation 1. So that was 6B square is equal to A, I can write as 4K square. A square I can write as 4K square. Right? I can cancel the factor of 2. So this becomes 3B square is equal to 2K square. Again, 2 is present over here. 2 must be present over here. Obviously 2, 3 में तो present होता नहीं है. Common sense. 2 must be present in B square. 2 is present in the prime factorization of B square. That means 2 divides B square. Right? If 2 divides B square, 2 will definitely divide B. Right? Now, again, you know that 2 divides A. You know that 2 divides B. That means 2 is a common factor of A and B. Of A and B. 2 is a common factor. Here, what did you assume? That there was no common factor. And you said this. Clearly, this is a contradiction. Now, this contradiction happened because your supposition was wrong. You assumed that root 6 is rational. This is wrong. That means root 6 is not a rational number. Right? Okay, before moving further, you could have obviously moved on with 3, prime factor 3, then it would have been 3 divides A, 3 divides B, and so on. Right? Some kids would be like, ma'am, do we have to do it with 3 as well? No. Because contradictions are again, no? If you just take one of the prime factors, you will arrive at a contradiction. So you do not need to talk about both 2 and 3. Right? You can either take 2 or you can take 3, whatever you like. Alright? Okay, next one. Prove that root 2 plus root 3 is an irrational number. Come on. Same method, obviously. Right. Obviously, you can pause the video and then move forward, but I'll discuss it. Now, I need to prove that root 2 plus root 3 is an irrational number. Now mind it, you cannot say that sum of two irrational numbers is irrational. That does not make sense. You can take your irrational numbers to be 2 plus root 3 and 2 minus root 3. Add them up, that is not an irrational number. Right? Mind it. So again, I have to utilize proof by contradiction. That means I will assume the wrong thing. The wrong thing in this case would be root 2 plus root 3 is rational. Right? That means root 2 plus root 3 can be written as a by b, where obviously a and b are positive integers. You need to write it no matter how many times, it's fine. You need to write it b not equal to 0, and then you have to say, if you want to say it, you can say it, but isme itna hoga nahi use, but okay. Okay, I can use the symbols, that's fine. Alright, now radical sign getting involved, let's just square it up. We know how to square things up, so squaring. Now, a plus b whole square, so a square, root 2 whole square 2, plus root 3 whole square 3, plus 2 into root 2 into root 3, that is 2 root 6. Right? This is a square by b square. Obviously, this is 5. Now, you have just proved that root 6 is irrational, right? So, I will try to isolate it. So, what I will do is, I will shift 5 to that side. So, I will write a square by b square minus 5. Right? Then 2 also I will transpose it. So, divide by 2. So, root 6 actually turns out to be equal to this. Right? Now, a by b was a rational number. The square of a by b would be a rational number. So, this is rational. This is obviously rational. Difference of two rational. Obviously, 2 is a irrational number. 2 is a rational number. Right? Division of two rational numbers, provided the denominator is not equal to 0. Yes, right. Is always rational. Right? So, right hand side is rational. Now, left hand side, you just know that root 6 is irrational. Right? So, again, you have arrived at a contradiction. That means your supposition is wrong. You suppose that root 2 plus root 3 is rational. This is wrong. That means root 2 plus root 3 is irrational. Again, you need to write 3 steps. Then only your answer would be complete. If you want, follow up. Cool? Right. Now, next is a very interesting question. I really like it. So, pay attention now. Prove that 999 plus 2222 root 3 cannot be represented in the form a plus root 3b whole square, where a and b are whole numbers. Hurry up. Prove that this number cannot be represented in the form a plus root 3b whole square. Right? I think you can definitely pause the video and then move forward. But I will discuss it now. Now, look at the language. Prove that this cannot be represented. Right? Look at the language. That it cannot be done like that. It gives you, maybe if I can, what? For this, eliminate the contrary, I can prove it. That means I might be able to use the proof by contradiction. Right? So what I'll do is, again, if I have to use the method of contradiction, I need to make a wrong supposition or assumption. Right? So wrong one. He says prove that it cannot be represented. Wrong assumption would be it can be represented. Can be represented as a plus root 3b whole square. Right? If possible. This is my assumption. Right? This is a very important assumption because this will give me a contradiction. Now, he says this can be represented, so this thing is actually equal to a plus root 3b whole square. Now, whole square is there. Definitely, I can open it up, right? So, a plus b whole square, you already know. So, I'll write it a square plus 3b square plus 2 root 3 AB. And left hand side remains the same. Right? Now mind it, root 3 is getting involved, root 3 is getting involved. You just proved that root 3 is irrational. Right? In the entire class we have been proving that root 2 is irrational, root 3 is irrational, root 6 is irrational, and root 3 is right there in the picture. Right? But first of all, left hand side will be root 3 and right hand side will. Let's combine the like term. So I will combine the like term. So shift this to that side and I'll take root 3 common. So 2222 minus 2ab is equal to a square plus 3b square as it is, and I will shift that to that side, so minus 999. Right? Now what I'll do is, since I want to isolate root 3, I will put this in the denominator. So let me write it. So this is 2222 minus 2ab. Right? So left hand side, just root 3 is there. I've isolated root 3. Right? This will be a very important thing. Now a square was a whole number, right? A was a whole number, a square would be a whole number. Whole number, subtract a whole number. Definitely, whatever the case may be, this is an integer, right? This is an integer. Ratio of two integers, provided the denominator is not equal to 0. Ratio of two integers is rational, right? Right hand side is definitely rational. And left hand side is root 3, which is an irrational number you just proved. So, irrational. So, irrational equal to rational. This is clearly a contradiction. Now, why did this contradiction arise? Because your assumption was wrong. You assumed that you can represent this as this, which is wrong. That means you cannot represent this as this. Where is it? Right? Okay. Now, we'll move on to the next set of questions. Let's see how you fare in that. So, write down. Check whether 4 raised power n can end with digit 0 for any natural number n. Justify. You need to justify. Such kind of questions do come in school exams, so you should know what to write. It is obvious, but you should know what to write. Right. Alright, let's discuss it quickly. Now I need to check whether this number can end with digit 0. Now any number ending with 0 would have a factor of 10. Right? Now it has a factor of 10, that means it has the pair 2 and 5. That means 2 is there and 5 is there simultaneously. If both of these are there simultaneously, definitely 10 would be there, that means 0 would be there at the end. So I need to check whether the number has 2 and 5 simultaneously or not. So I have the number 4 raised power n. Obviously I will try to prime factorize it, but first I'll write 4 as 2 square whole raised power n, which is nothing but 2 raised power 2n. Now 2 raised power 2n, as in I'm multiplying 2 how many times? 2 into 2 into 2, so on into 2. How many times? 2n times. Right? Now I need to check whether 2 and 5 both are present or not. Now 2 is present. Yes, pick any 2 you like. Is 5 present in the prime factorization? The answer is no. 5 is not present. Now, if 5 is not present, do you think 2 into 5 is present? Of course not. Is not present. That means 10 is not present. Right? If 10 is not present in the prime, I should not say prime factorization, that means the number cannot end with 0. Cannot end with 0. If you write all of these, then only you will get full marks in the test. So careful. Right? Next one. Write down. If P divides A and Q divides B, where P and Q are prime, then prove PQ divides AB. PQ divides AB. Now this is a very obvious thing, but in these kind of questions it is very important to know what is right and what do you have to write, that also, because this is beginning of number theory. If you learn how to write in number theory, you probably can do the complex questions. So in these so-called easy questions, you should know what to write, right? Because if you get to know what to write, your logic will increase, trust me, right? Your logical ability will increase. That means automatically the topic of number theory would be better. So try to write the logical sequencing of the steps. It is obvious, yes, but just articulate it. That's it. Right? Now I'll discuss. Now he says P divides A and Q divides B, where obviously P and Q are prime, because you usually talk about the prime factorization. Then prove PQ divides AB. Now I need to talk about whether PQ divides AB or not. So I need to talk about what? Divisibility of which number? Of AB. Whenever divisibility comes into the picture, I will be interested in the prime factorization. I want the prime factorization of AB. Now it is consisting of two numbers, A and B. So what I do is I will talk about the prime factorization of A and the prime factorization of B respectively. So A and B. Now he says P divides A and P is a prime factor. If P divides A, that means this prime factor would be here in the prime factorization. So P to hoga here. Into. There would be some other prime numbers as well. So let me name it to be let me name it to be P1 into P2 into so on. I do not know how many they are, so let there be M prime factors like this one. These are M in number, 1 to like M tak. And then P is there, obviously. Also, do not confuse this P and this P1. These are completely different. Right? Different variables are there. Okay. Now B. Now he says Q divides B, that means Q must be present in the prime factorization. There would be some other prime factors, so Q1, Q2, into so on. I do not know how many they are, so Qn. Right? So these are n prime factors along with Q as well. Now I know the prime factorization of A, the prime factorization of B. I want AB, so A and B. If I want AB, I'll just multiply. So A, B is this into this. So P into P1 into P2 into so on into Pm into this, so Q into Q1 into so on into Qn. Right? This is the prime factorization of AB. I need to check whether PQ divides AB or not. Now PQ, अब इसके prime factors देख लें, दो ही होंगे, right? There are just two prime factors, that is P and Q. Check whether P is present in the prime factorization of AB. P is present? Yes. Check whether the other prime factor, that is Q, whether it is present in the prime factorization or not. Yes. Since the prime factors, in fact, all the prime factors of this number is present in AB, that means PQ divides AB. Right? Very simple thing, but you should know how to write it. Alright, let's do another one. Given A and B as positive integers and C is prime, if P divides AB and P does not divide B, then prove P divides A. Come on, very obvious, you need to write the proof though. I think sufficient time, let's discuss it now. You can always pause the video and do your question. Right? Now he says that A and B are positive integers and P is a prime number. If P divides AB and P does not divide B, then prove P divides A. Right? Okay. Now the thing is, I would require the prime factorization of A, definitely, because I need to prove it. Right? And obviously, I would need the prime factorization of B as well. Right? Okay. So let me consider the prime factorization of A as well as B. Now, I do not know the prime factors. I do not know how many they are. What are they? I do not know. So let me consider them to be P1, P2, into so on into Pm. I do not even know how many prime factors are there. That's why everything is a variable here. It's okay. It's fine. We are not scared of variables. We like them perhaps. Now B. I do not know the prime factors, so let that be Q1 into Q2 into so on into Qn. Now, eventually I need to talk about AB, right? So what I'll do is, I will just multiply it and write the prime factorization of AB. So that is P1 into P2 into so on into Pm into Q1 into Q2 into so on till Qn. Right? Now, he says P divides AB. Okay? And P does not divide B. First of all, he says P divides AB. That means P must be present somewhere over here. Right? Either it can be P1, either it can be Pm or Q2 or Q1. Right? He says that. But he says P does not divide B. P does not divide B. That means in the prime factorization of B, P will not come. Right? P will not be present over here. So that means this prime factor cannot be P. This prime factor cannot be P. So Q1 is not equal to P. Q2 is not equal to P. So on, you can say that Qn is not equal to P. Right? Coming back to this, यहाँ पे तो P present होना था. अब Q1 में नहीं है, Q2 में नहीं है, so on Qn में नहीं है. यहाँ पे तो P है ही present है. Right? That means either P1 has to be P, or P2 has to be P, or so on Pm has to be P. Right? So we arrived at this. Either P1 is equal to P, or P2 is equal to P, or so on Pm is equal to P. Because P has to be one of these prime factors itself, right? अब अगर इन्हीं prime factors में से that means ये है क्या? This is nothing but the prime factorization of A. If P is present over here, P is present in the prime factorization. If P is present in the prime factorization of A, do you think P will divide A? The answer is yes. Now, you should pat yourself if you have thought about the logical steps in this manner. Very trivial, but the implication in this question is very important. Alright, now let's move on to the next one. Next one is very easy, but it is given in the NCERT book, so you should definitely pay attention to it. So right now, let P be a prime number. If P divides A square, then prove P divides A, where A is positive integer. This is the result that is given in your NCERT book, and this is the proof, so you should be able to do it. Hurry up. Alright, I think sufficient time. Let's discuss it. Alright, now he says P be a prime number. Okay, P is a prime. If P divides A square, then prove P divides A. Right? That means I would need to talk about the prime factorization of A. So let me talk about the prime factorization. Now, I do not know anything about it. In fact, I need to prove that P divides A. Right? So मुझे नहीं पता, so I will take my prime factors to be P1, P2 into P3, then so on into Pm. Right? Now, A square is coming into the picture, so A square is nothing but A into A. Right? Or let me just write it directly itself, A square. Right? So you have squared the left hand side, square the right hand side. This will turn out to be P1 square into P2 square into P3 square into so on into Pm square. Now when I say P1 square, this is nothing but P1 into P1, right? When I talk about P2 square, this is P2 into P2. And so on. When I say Pm square, this is Pm into Pm. Right? Now notice P1 is here, P1 into P1. When P1 is here, P2 is here, then P3 is here, so it is here, Pm is here, Pm is here. That means, yes, the prime factors which are present in A square, they are also present in A. Right? यहाँ पे prime factors double है, that is the only thing. मतलब उनका number, quantity. But these are the same one. P1 यहाँ पे भी है, P1 यहाँ पे भी है. Right? Now he says P divides A square. P divides A square. So that means in the prime factorization of A square, P would be there. Right? maybe P comes out to be here. Now, I know that any prime factor is occurring twice, right? So, P will not be lonely, it will have P into P. Now, mind that we just established whatever prime factors we have over here, those are present in it. Now, P is a prime factor of A square. That means P would be present over here. Right? If P is present in the prime factorization, that means P would definitely divide A. Right? Now, this is a very simple proof. And in the root 2, prove that root 2 is an irrational number. We said this thing, right? 2 divides A square. This implies 2 divides A. Right? When I said this, basically I said this. Why? P be a prime number, 2 be a prime number. If 2 or P divides A square, this implies P divides A. This you've already indirectly used. Right? This is a general proof of it. Alright, with this we'll end the class. Home assignment has been uploaded. Please do it on time. And I think that's it for today's lecture. I will see you next time. Thank you.